Hey there, calculus people. I'm going to do a short little video on continuity proofs, which a lot of people I feel like have sort of a vague understanding of, but not a really straight, strict, logical, rigorous understanding. So I'm hoping I can bump you folks up if you meet that description. I have here went up. I have a function here, bam, that is definitely discontinuous, right? Removable discontinuity. And I have here the definition of continuity. If you want something to be continuous, then the limit as we approach c darn well better equal what f of c is, okay? So here we don't have that, right? Because my limit is approaching 3, but guess what f of c is? It's actually, or f of 6 in our case, is actually 7, right? So 3 does not equal 7. Clearly this is discontinuous. Let me show you how you lay it out, okay? I just examine the left side of the equation, then I examine the right side, and then I just see if they're equal. And then I make my call. If they're not equal, discontinuous. If they are equal, yay, continuous, okay? So, let's look at this left-hand side first. Let's look at the limit as x approaches 6 of f of x. And, look at it equals 3. Bam, okay? So I've now examined this side of it, and I see that it equals 3. Now, you're not done. Like if you just said, oh, therefore the function is discontinuous, that you have not used the definition of continuity at all. You've not examined this to see if it equals or doesn't equal f of c. We got to look at that. So let's do it. F of 6 is 7. Aha. Are these equal to each other? They are not. But here's the thing. If you merely were to say right now, because remember, this is not on your, ideally, this line here would not be on your piece of paper. You would just be, sort of using it mentally and building a case. If you just said f of x is discontinuous, sorry, I'm abbreviating here, discontinuous, I don't know if you get all the points on the rubric, and on an AP test, because it's in there, you're understanding it, but it's like, you gotta actually use this definition. So say it out, not out loud, but say it in writing. So I'm actually gonna say, hey, the limit as x approaches 6 of f of x, this thing here, does not equal f of 6. Now have I explicitly used this definition? Absolutely. So now I can go ahead and say, therefore f of x is discontinuous, sorry, so sloppy, discontinuous at x equals 6. Shazam, QED that puppy, right? So, that's my strategy. Look at this side, figure out what it is. Look at this side, figure out what it is, and then see if they're equal or not. And then you can make your call about the continuity. Make sure you write this down, though, okay, so that people know, hey, I know what the definition of continuity is, all right? Don't make them infer that you probably know it, all right? Actually use it explicitly. Let me give you one more example that might be a little trickier. Let's say that instead of a removable discontinuity, let's say we have a jump discontinuity, okay? So, that's fine. Let me just erase. Great. So now I'm going to use the same strategy, but can you tell, like, I'm just being intelligent about this. Can you tell the limit doesn't even exist there? Like, my left hand does not equal my right hand limit, right? So this thing, like, just looking ahead, before I even write my proof down, I know that I'm going to say this doesn't exist. This equals 7, but since this thing doesn't exist, it can't possibly equal that. We're going to have a discontinuity. That's my overall strategy. But how do I show that this thing doesn't exist? Well, the calculus graders, they're smart about limits. They know if the left hand doesn't equal the right hand, you got DNE. So that's what I'm going to show. The limit as x approaches 6 from the negative side equals 3. But the limit as x approaches 6 from the positive side, that equals 7. Therefore, I'll just write it over here. Therefore, the limit in general, the limit as x approaches 6, does not exist. Now, this is mostly a formal exercise at this point, but I know that I want to use this definition in my proof, so I'm actually going to say, hey, f of 6 equals 7, which is a little silly, but I'm going to do it because, again, if you just say right now, like let's say you didn't have this line, if you proved the limit didn't exist, and then you said, therefore, f of x is discontinuous, yay, I don't know if they give you the points. You have not actually shown that we violate this equality. So that is what I'm going to show. So there's beyond a shadow of a doubt. So limit doesn't exist, but f of 6 equals 7. So I'm going to say the limit as x approaches 6 of f of x does not exist. Therefore, it can't, that's a therefore. I know I'm writing so fast. Therefore, it can't possibly equal f of 6. Therefore, f of x is discontinuous at x equals 6. Shazam, QED, yay. Okay? So hopefully that helps you lay out the logical order of things, all right? Make sure in your last step you show either that equality is there or that it is not there. Actually write it out, okay? Just like we did here. Okay, good. Hope that helps.